Hey, fifth grade, we're on page 141, rewriting fractions with a common denominator. We have been practicing this, but we're going to keep practicing it because it just takes some time to get comfortable with it. Okay. TV show hosts Ben and Isa. I was thinking it was Isla. We'll say Isa. Ben and Isa are preparing small pieces of French toast from slices of bread. Ben cuts his slice into 2 equal sections. Isa cuts her slice into 3 equal sections. All of the sections were supposed to be cut in the same size pieces. Draw a visual model to show what Ben and Isa could do to correct the sizes of their sections of French toast. Okay, I'm going to do some like circle graph type things here. I'm actually going to scoot that down. So I'm going to put a B here for Ben and an I here for Isa. Okay, and Ben cut his into 2 equal sections. So he split his in half, and Isa cut hers into 3 equal sections. You kind of like do like top to the bottom and then off to the side, off to the side. Isa did 3. So we need to fix this so they can end up being the same size pieces. Okay. Again, let's see here. Okay, so start with what they've got. Ben's got straight down the middle, and Isa has thirds. Okay, so if you split your half into 3 2 times, you end up with 6. If you split these thirds in half, guess what happens? You end up with twice as many pieces, which would be 6. Okay, so like draw an arrow from here to there, and look at this. Essentially, they just want us to see that 1/2 is the same as 3 out of 6. Okay, and you can even color this in if you want, like if that helps you. Like 1/2 is the same as 1, 2, 3 out of 6. We've been doing some of this like visualizing, excuse me. And like here, 1/3 is the same as 2/6. Okay, so just a little review there to touch base. Page 142. The circle represents all the people who watch the morning show. What equivalent fractions can you write to represent the different ways people watch the morning show? Okay, list non-zero multiples. So you're not starting like 0, 2, 4, 6, 8. You just start at 2. Okay, that's what that means. Non-zero multiples of 2, 5, and 10. So on the 2, you're actually going to rewrite it and start with 2. 2, 4, 6. Oops, I missed a comma. 2, 4, 6, 8, 10, 12. Okay, and we could keep going, but we'll switch to the next one here. Start with your 5, 10, 15, 20, 25. Okay, and the 10, we've got 10, 20, 30. Don't forget your commas. I almost missed it again. 40, 50. Sometimes you have to count a little more than others, but the reason they're having us list common multiples is so you can find like which one is in both lists. Well, 2, 4, 6, 8, 10. Every other one of 5 ends with a 0, and we know everything times 10 ends with a 0, right? So the common multiple of 2, 5, and 10 is 10. And that's actually your least common multiple. If you kept counting a bit, you would get to 20 on all of the lists. But we didn't get there this time, right? So 10, use the common multiple to rewrite the equivalent fractions. So how do we switch this denominator from a 2 to a 10? Well, we have to take it times 5, do the exact same thing to your numerator. So 1/2 is the same thing as 5 out of 10. It just looks different, right? 5, you have to double it to get it to a 10. You have to do the same multiplication to the numerator that you did to the denominator. So this is the same as 4/10. It just looks different. And this, you just take times 1, it stays the same, right? Times 1 times 1, 1/10. Okay, connect to vocab. Fractions that are the same amount or parts are equivalent fractions. So it's the same thing, they just look different, okay? For example, 1/3 and 2/6 are equivalent fractions. It's like the same chunk of the pie, right? Same amount of the pizza. How can a common multiple and equivalent fractions help you add and subtract fractions? Well, we know that we need a common denominator. Okay, so common multiples help us find a common denominator so we can add or subtract correctly. Okay, in other words, you need a common denominator to add or subtract fractions. Okay, it does not work if you do not use a common denominator. Letter E, write a numerical expression using equivalent fractions that models the people who watch the morning show. So if you glance up here to letter C, and I'm going to have to scroll down. So up at letter C there, we've got 5/10 plus 4/10 plus 1 more tenth. And when you add it all together, you should get 10 out of 10, right? Or one whole pie chart. So 5, 9, 10. Yep. There we go. Page 143. Number 2. Trina makes decorations using wire. She has one piece of wire that is 1/6 of a foot and another piece that is 3/4 of a foot long. What equivalent fractions represent the amounts of wire Trina has? Find the product of the denominators of each fraction. How is your answer related to the common multiples of 4 and 6? Okay. Hoofda. Okay, excuse me, guys. I'm going to do the connective vocab really quick. A common denominator is a common multiple of 2 or more denominators. Any 2 or more fractions can be expressed as equivalent fractions with a common denominator. Okay, so find the product of the denominators. Product is a fancy word. Hi, Nickel. Product is a fancy word that means to multiply. Okay, so find the Nickel. Oh my goodness. Excuse me, you guys. I'm sorry. Nickel is like laying on my teacher bag right now. I'm being so silly. Come snuggle. Okay, product means to multiply. Find the product of the denominators that gives you a multiple of both numbers. It's not the least common multiple, but it's something you can use. So how is your answer related to the common multiples of 4 and 6? Well, 4 times 6 is 24. How is it related? 24 is a multiple of 4 and it's a multiple of 6, but we literally multiplied them together to figure it out. What equivalent fractions with a common denominator can you write for 3/4 and 1/6? Well, you could make them out of 24 and do this times 6. Same with the numerator, times 6. Okay, take this times 4 to get your 24 denominator. Take that times 4. And really, you've got 18 24ths and 4 24ths. Okay, so it's the same thing, but now you can add, subtract, compare, whatever you need to do. You could use the least common denominator, which when you count by 4 and count by 6, 12 actually matches before 24 does. And then it's going to be a little easier for our brains to keep it as simple as possible to like visualize these. Okay, so 4 times 3 gives you 12. Do this with the numerator. Double this to get 12. Do that with the numerator. So you've got 9/12 and 2/12. Okay, and it would probably behoove you to write both of these down. Behoove means like it would be wise of you to write both down, just because there's so many different ways to do the same thing, right? Because it's math and that's complicated and fun. Letter C, what numerical expression using equivalent fractions models the amount of wire that Trina has? All right, so we can put the 9/12 together plus the 2/12, or we could say 18 24 plus 4 24 would show us the amount of wire. And that's all you have to do there because it just says what numerical expression. Here's the deal. It's me, right? So I'm going to solve it for you. Put it together. 9/12 plus 2/12 gives you 11/12. 18 plus 4 gives you 22 out of 24. What do you notice about 22 and 24? Very good. They're both even. So we can simplify or reduce this make it simple for our brain, divide them both by 2, we end up with 11/12. So it's the exact same thing. They're just using different numbers to manage them and make them look different, or make them the same so you can compare them and do other things. Okay, number 1, Ava, Kate, and Jin all bring the food to a picnic. Ava brings 3/4 of the food, Kate brings a 1/6, and Jin brings a 1/12. Write a numerical expression. Here we go. Using equivalent fractions with a common denominator, okay, to model the amounts of food they bring. So we've got a 4, a 6, and a 12. I like this one as a common denominator. Let's not go any higher than that or smaller when you're thinking about fractions. So 4 times 3 gives you 12. Take the numerator times the same thing. Okay. 6 times 2 gives us 12. Maybe I should just be doing this. And then 1 times 2. That's way neater. So rewriting this, 3 times 3 is 9. You put that over 12. Okay, 1 times 2 is 2. And you put that over 12. And this is already over 12. Oops, that's hard to see. Okay, so that's the same as 2/12, 1/12, 9/12. So I'm just going to type it. But if I were you, I would write this vertically, like up and down, like we usually do. Okay, so that first fraction is 9/12. Numerical expression here, plus 2/12 plus another 1/12. And they're not even asking us to solve it. But if we check 9, 10, 11, 12, add it all together, you would get 12/12 or 1 whole. In other words, in this situation, all of the food. Okay. Number 2, find the common denominator. Use the common denominator to write equivalent fractions. You have lots of options. I would stick with your least common multiple. In other words, count by 4, 4. 8, 12, 16, count by 8s, 8, 16. 8 matches first in both lists, right? So to make the 4 into an 8 here, you have to double it. So you have to do the same to your numerator, 3 times 2, and then the 4 times 2. So that gives you 6/8. And then you're going to do a comma, leave some space there, and the 1/8 stays the same. And again, personally, my tip for you is to write your fractions like this, because it just makes life easier. Comma can go down here like normal. To add and subtract, multiply and divide when we get there, I would not write them sideways like this. I'm just doing that because it's a little neater when I type it, as you can see, right? Okay, number 3, we've got a 4 and we've got a 6. Pardon me for a second. Nickel! Hey, buddy. Okay, so counting by 4s and counting by 6, 12 is the thing that will match first, okay? So 6 times 2 gives you 12. Do the same thing to the numerator. Were you trying to get into food, Nickel? I heard something. That didn't sound good, but I'm focused on math, so you knew I was distracted. Okay, take the 4 times 3 to get 12. Take the 1 times 3. Our common denominator is going to be 12. Okay, and that first one, we've got 3/12, do a comma, a little space there, and then 10/12. Right, that's some good practice. Reminder that letter L in IXL has excellent practice on all of this stuff for you guys, okay? Last page of our lesson, 144. The morning show, we're back to that. The morning show has a 1/5 hour weather section and a half-hour news section. How can you determine the amount of time spent on weather and news without using drawings? Well, you can take that 1/5 and that half and add them together. I'm going to use this line unlike I normally would in a workbook. Okay. 1/5 plus 1/2. We're going to add them together. I'm going to Christmas it up here. We're in a blizzard day. Double that. You have to take this times 5. Okay, so times 2 times 5. And so we've got 2/10 plus 5/10. You know what? I just realized they're not even asking us to solve this. They're asking us to talk about how to solve it. Whoopsie. Okay, so how can we do that? Change denominators so they are the same. Multiply numerator by the same numbers. Okay, and then then add. So the reason you want a common denominator is so you can add those equal parts, right? So like a fifth of something and half of something are two different chunks of whether you're looking at a fraction strip or a pie, right? Like a circle graph kind of fraction thing. They're different size chunks and you need to be adding or subtracting the same size. So that's where that comes in. Okay. Number 5, use a common denominator to write equivalent fractions. So we don't even have to change both of these. We've got a 2 there and a 12. I'm just going to take that 2 times 6 to make it into a 12. Whatever you do to the denominator, you do to the numerator. So here you've got 6 over 12, comma, and the 5 over 12 stays the same. Okay. And again, you're going to write that so much neater than I am, that I just did. Actually, maybe I can scoot it. It'll look like that answer line is my fraction bar. Oh boy. Okay, 3 and 6. Let's double the 3. That brings it to a 6. The 6 can stay the same. So same thing with the numerator. Here you've got 2 times 2 is 4. Put that over 6. And then the other one stays the same because it's already in 6. So you've got 4/6 and 1/6. At this point in the video, oh yeah, we should put a comma between them so we know that they're separate numbers. Okay. At this point in the video, I would encourage you to pause it and try numbers 7 through 10 on your own and check your answers when I go through it. Maybe even try number 11. Okay. And see how you're doing. Okay. 8 and 3. 24 is your least common multiple here. So you're going to take the 3 times 8. You're going to take the 8 times 3. Okay. Do exactly the same thing to the numerator that you do to the denominator, because anything over, like any number over itself, like 8 over 8 or 8 out of 8 pieces of the pizza is the one whole. So really we're taking these times one whole. We're just kind of doing it in a funky little way here. So here you've got 16 over 24, comma, and then 3 times 3 is 9, and that one's over 24. Okay, so on your line, you'd write this, but nicely as your fraction. All right, here, 4 times 5 gets you to 20. You have to take your numerator times 5. This you would have to take times 4 to get it to 20 times 4. And on your line, you've got 5/20ths. And 20ths is the denominator there. 3 times 4 is 12. So 5/20ths and 12/20ths. 4 and 6. We just did that not too long ago, I think. So 4 times 3 is 12. Take your numerator times 3. 6 times 2 gives you 12. Do the same with your numerator. Sorry, this is hard to read. 3 times 3 is 9. 12. Thank you guys for making the best of virtual learning. This is not as fun as seeing you in person, but you are just troopers. Anyway, 1/6 is the same as 2/12. So those are the equivalent fractions. You're just rewriting them so they both have the same denominator. All right, 3rds and 5ths. Let's take this one times 5 to get it to 15. Take your numerator times 5 to keep it proportional to the actual fraction. Take your 5 over here times 3 and take your numerator times 3. So let's rewrite these. Here we've got 10 over 15. Oops. The comma between them, and then you've got what looks like, hopefully, 9 over 15. So 10/15ths and 9/15ths. All right, last problem. STEM. Temperature is one factor that determines the weather. In Tavernier, Florida, the average monthly high temperature in degrees Fahrenheit is in the 70s for a third of the year, in the 80s for half the year, and in the 90s for a sixth of the year. Write a numerical expression using equivalent fractions, okay? So not just half plus a third plus a sixth. We have to use equivalent fractions with a common denominator to model the part of the year with these average temperatures. All right. It's on. Let's do this. So we've got a 3, a 2, and a 6. 2, 4, 6, 8, 3, 6, 9, and a 6. Let's keep 6 as our denominator. Okay. So double that to get it to 6. Double your numerator. So it's the same fraction. It's just going to look different. 2 times 3 gives you 6. Take your numerator times 3, and the 1/6 is going to stay the same. So 1/3 times 2 times 2 over 2, essentially. 1 times 2 is 2, 3 times 2 is 6. So you have 2 sixths, right, an expression. So 2 sixths plus 1 times 3 is 3, 6 plus, and yay, okay, and then we've got just the 1/6 left. And when you add all of these temperatures together, you should end up with one whole, which is 6 out of 6, right? So 2, 3, 4, 5, 6. Yeah. And just a warning for you guys, every time you add fractions together, you may not get one whole every time. If you're talking about the entire pizza or everyone that watches the morning show or all of the temperature Florida through the year, it should add up to that one whole thing. So that's just a nice way to double check your work, make sure you did it correctly. But again, if you're adding like a third plus a fourth, you're not going to end up with one whole in that situation if it's just kind of randomly adding. Okay. Alrighty, your worksheet is due on Monday. So get a head start on that. Do what you can. I will see you tomorrow. Thanks for hanging in there, guys. You rock.